So we're going to go back to all those T-charts that we did for unit conversions, right? Do you remember how to do a T-chart? We want to cancel the unit we don't want on the bottom. The unit we do want needs to be in the top right. The first step of a T-chart is always to write what you know, right? That goes in the top left of our T-chart. But we're gonna do a lot of practice with this today, and this is a skill that needs to be. This is an essential skill for chemistry. Calculating molar mass and doing these gram to mole conversions is a big, big skill for us in chemistry. So this is something that you need to be able to do very well. Okay, we're going to do it enough. I think you can do it in your sleep. But I need you to make sure that you're asking questions if you're not understanding as we go. Okay? First of all, can someone tell me what 1 mole is? 6.022 times 10 to the 23rd, what? Of what? Of anything. Of anything. 6.022 times 10 to the 23rd of anything is considered 1 mole. Okay? So most of the time we think of that in terms of atoms or molecules or whatever. But it could be anything. Right? I could have a mole of baseballs, right? That means I have 6.022 times 10 to the 23rd baseballs. Okay? All right. So we're going to look at how to convert between grams and moles. How do we take a quantity of a substance in grams and convert it to the number of moles? We use moles scientifically a lot more, so we need to be able to convert. Okay, so we're going to be able to use an element's or a compound's molar mass to convert between the number of grams of a sample to the number of moles in a sample. Okay, and this is an essential conversion for us. We don't like to deal with quantities in grams. We like to deal with quantities in moles. Okay, it kind of gives us a more universal way to look at a quantity of a substance in moles. Okay. So if we have the number of moles of a substance, we're going to be able to tell exactly how many grams are in that substance as well. Okay? We need to understand the difference between those two things. They're both quantities. Grams is a measured quantity. You can measure it with a balance or a scale. Moles is a little bit more of an abstract quantity for us, but it's still a quantity. It's still an amount of substance. Okay? So when we convert from grams to moles, we're going to walk through the steps of that, and then we're going to do a lot of practice with them. So I want you to go ahead and write the steps out, but we're going to get some practice to go with it. Okay? So this is all within a T-chart. Okay? To convert grams to moles, you're using a T-chart here. Okay, and the first step to any T-chart is going to be to write what we know. Practice here with our mole to gram conversions or gram to mole conversions. So our first problem says, how many moles are in 74.2 grams of LiCl, which is a compound called lithium chloride? Okay, so we're in grams. We want to go 2 moles. Okay, so first step of our T-chart is to do what?
Write your note.
First one's write what we know. So we're going to start our T-chart by writing what we know. 74.2 grams, and I want you to include the compound in your T-chart. We're going to make our T here. Okay, I want to go from grams to moles. So what unit needs to go on the bottom right here? Grams. Okay, it needs to go diagonal from grams here because that's how we cancel. I want to go from grams to moles. Okay, and what did I tell you about the rule is for the moles? It gets the 1. Okay, so let's look at this particular section of our T-chart. This is going to tell us how many grams of LiCl, or lithium chloride, is in 1 mole of lithium chloride. Okay, this section right here tells us this many number of grams is in 1 mole of lithium chloride. So how do we find this number? How do we know how many grams is in 1 mole? We find the molar mass. So in this section right here, it needs to be the molar mass. Okay, so let's calculate molar mass of lithium chloride. Let's go to 2 decimal places. Calculate lithium chloride to 2 decimal places. $42.39. Yeah? Do we agree?
Yes.
42.39 grams is in 1 mole of lithium chloride. So I didn't do anything with the 74.2 yet, or yeah, 74.2. I'm going to wait and do all of that math at the end. So when we do a T-chart, we go one row or one column at a time. Okay? Once I get into this column right here, I'm telling that in 1 mole of lithium chloride, there are 42.39 grams. Okay? So now we've canceled the gram unit, and we're left with moles of lithium chloride. Is that what we want to be in? Yeah. Yeah, because our problem asks for how many moles. So that means we're going to multiply across the whole top, divide by the whole bottom, and tell me how many moles are in this particular sample. Yep.
Okay, so where do you want it rounded to?
Let's go 2 decimal places.
I know 42.4.
42 point what? I'm not as concerned with significant figures when we do unit conversions, because this 1 right here would throw us way off on our accuracy. So I usually just like to go to 2 decimal places. Okay? So tell me how many moles we have. 1.75 moles of LiCl. Okay, so now we need to go back to check to make sure our answer makes sense. Okay, if we know that 1 mole of lithium chloride weighs 42.39 grams, and we started with 74.2 grams, that's almost 2 times as much, right? So it makes sense that we have almost 2 full moles of lithium chloride. Do we agree there? You can check yourself by looking at that original starting amount to see if it compares, how it compares to your molar mass. Okay, because we know the molar mass is of 1 mole, so we can go back and check that. Okay, any questions here? All right, let's try another one. How many grams are in 0.42 moles of MgNO3, which is called magnesium nitrate? So our first step in our T-chart is going to be to write what we know. Okay, and I want to get rid of what unit? I want to get rid of moles, and I want to go to grams. Okay, and what do we know about moles? It always gets the 1. Okay, moles always gets the 1 in these conversions. So now our next step here is what value is going to go in this particular spot in our T-chart? The molar mass. Good, the molar mass needs to go here. So we need to calculate molar mass so it can fit in that slot in our T-chart. So when we're calculating molar mass, how many magnesium atoms do we have? 1. How many nitrogen atoms do we have? 2. And how many oxygen atoms do we have? 6. Okay, because this 2 distributes itself throughout that parentheses. It distributes. So we have 1 magnesium, 2 nitrogen, and 3 oxygens. Okay, 148.31. That's what I had. Okay, or very close to that. You could be a couple hundredths off either way, just depending on the way you rounded. Okay? Any severe disagreements here? Good. Okay, so now that we filled in our molar mass, we've canceled our mole units, and we're left with grams of magnesium nitrate. Is that what we want our answer to be in?
Yes.
Yes, good. So let's multiply across the whole top, divide by the whole bottom, which means we get 62.29 grams. Okay, so now we can go back and check our answer. We started with a little under half a mole. So does that make sense that our final answer is a little under half of our molar mass? Yeah, good. Okay, so go back and use some reasoning to make sure that your answer makes sense, okay? I would suggest that you do cross out your units when you cancel them so that you ensure that you're left with the correct unit, because sometimes those can get flip-flopped. The top and the bottom might get flip-flopped, and then they don't cancel correctly, which means your math is not done correctly, okay? So make sure that you cross those units out once they've canceled. We're done with moles, we're left with grams, okay? Okay, the bottom two are going to be done by yourself. Okay, I'm going to be walking around, so please ask questions if you have them. But we'll see if we agree at the end here.
And even really in most problems, we can round that to 4D or to 12, and it's not going to make a huge difference. But since I specifically asked 2 decimal places, that's what I want. Just take it home to your dad.
Okay.
Is that your dad?
Okay, so I'm going to go ahead and show what I had. This is what I saw most of you had for your answers. So on this first one, find the number of moles in 321 grams. We had 3.21. You can be in that ballpark, right? 3.19, 3.22-ish. And then for number of grams, we were at about 77 point something. Okay, 77. Here's our work for both of those. Do we have any major questions about that? From what I saw walking around, everyone looked like they pretty much had the right process going, which is good. Okay. Any major questions? Okay, which means we're going to look between moles and molecules, or moles and atoms, number of atoms, okay? Avogadro's number helps us link the number of moles of a substance to the number of atoms / molecules, depending on what we're looking at. If it's a compound, we're going to look at the number of molecules. If it's a single element, we'll just look at the number of atoms. Okay, those two words are used pretty interchangeably for this section of it, but understand that if we're looking at a compound, we're finding the number of molecules. If we're looking at an element, a pure element, we'll find the number of atoms. Okay. So Avogadro's number is 6.022 times 10 to the 23rd atoms per mole, okay, or molecules per mole, or baseballs per mole, or roses per mole, or donuts per mole, right? Every single thing could be a mole of something if you have enough quantity of it. Okay, but it's 6.022 times 10 to the 23rd. That number needs to be burned into your little brain, okay? Burned, burned, burned. 0.73 moles of lithium. How many atoms are in this sample? Okay, this is a regular conversion, a regular T-chart type problem. This is going to walk us through the steps, so we're going to work it just like a regular practice problem here. Okay, regular conversion. I'm not going to walk it through the PowerPoint. Okay. The same rules apply here in that the mole always gets the 1. Right? Because Avogadro's number tells us that in 1 mole, there is 6.022 times 10 to the 23rd of whatever. Okay, so the mole always gets the 1 in these conversions as well. All right, so first thing that we do is we're going to write what we know. So we have 0.73 moles of lithium. How many atoms are in that sample? So we want to go from moles to what? Moles to atoms. So what unit needs to go on the bottom? Moles, good. Moles of lithium, and then on the top needs to be atoms of lithium. Moles always gets the 1. Now tell me how many atoms are in 1 mole of lithium. 6.022 times 10 to the 23rd. Okay, so now we're going to do the math because we've crossed out moles. We're done with moles. We're left with atoms of lithium, which is what we want. We're going to solve the math here.
How much do you want us to round it to?
Let's go to 2 decimals. Okay, and I know technically this would be 396, which is really 3 or 4.40, but okay, 4.39 or 4.40 times 10 to the 23rd. If I count it out individually, 8.23 times 10 to the 23rd grains of sand, how many moles of sand do I have? Okay, if I had the time to do that, or the patience, I want to find out how many moles of sand that is. I can do anything. Okay? 8.23 times 10 to the 23rd grains of sand. That's going to be what we write because that's what we know. And it's grains. So what unit needs to go on the bottom now? Grains. Yep, grains of sand. And I want to go to moles, or just MOL. Moles. Okay, and what do we know about moles? It always gets the 1. Okay, and how many grains are in 1 mole of something? Yep. All right, so now we do the math. Multiply across the whole top, divide by the whole bottom. Okay, by using molar mass and Avogadro's number, we can convert between grams and atoms, or grams and molecules. Okay, our T-chart's going to be 1 step longer this time. What do you think the middle step has to be between grams and molecules? Moles. Has to be moles. So there's no easy conversion between the number of grams and the number of molecules. So we've got to convert 2 moles and then we go to the other. Okay, moles is always our middleman. Okay, so we have to convert to moles in the middle. Okay, everything is going to look the same in our T-chart. Our conversions are going to look the same, except we're going to have an extra step. We're going to add 1 more column to our T-chart. Okay, so it has 3 columns or 3 spaces instead of just 2. Okay, so we go from grams to molecules, or molecules to moles to grams. How many salt molecules are in 14.52 grams of NaCl? Okay, and NaCl is salt. How many molecules are in 14.52 grams of that substance? So we're going to find out exactly how many little individual salt molecules are in 14.52 grams of that substance. Okay, and remember in our T-chart, we set everything up and we do all the math at one time. So there doesn't need to be any math that's done while you're doing your T-chart, with the exception of calculating the molar mass. Okay. So first thing we're going to do here is write what we know. 14.52 grams of NaCl. Okay, and if we're going from grams to molecules, can we go directly from grams to molecules? No, we need to go from grams to what?
Moles.
Grams to moles. So grams goes on the bottom because we have grams here. Needs to cancel. So grams of NaCl to moles of NaCl. Oops. Okay, and we can wait. I want to fill in all the units first, and then we'll go back and calculate molar mass, things like that. Okay, so is moles of sodium chloride what we want to end up in? No. So we need to get rid of moles, which means it needs to go on the bottom. And what needs to go on top?
Grams.
We want to end up back in grams? No, we want to end up in molecules or atoms. So molecules. Okay, so now we can go start filling in our numbers. Okay, what do we know about moles? It always gets the 1. So in both places it gets the 1 here. Both places. Okay, what goes in this section of our T-chart here? What goes with grams? Molar mass. Okay, molar mass. So the molar mass of sodium chloride I had at 58.44. That's what I had. Okay, and that's keeping everything at 2 decimal places. So Tell me how many molecules are in 1 mole of salt. Good. 6.022 times 10 to the 23rd. Okay, so we didn't do anything different, nothing groundbreaking. We just combined these two T-charts into one. We have 3 spaces because we needed to go from grams to moles to molecules. So now we multiply across the whole top, divide by the whole bottom. Should we be expecting a big number here or a small number?
Big number.
We should be getting a big, big, big number, right? Because we're solving for the number of molecules. So we should be having a number here that's got an exponent to it, times 10 to the 20 something. Times 10 to the what?
24.
I had
23rd.
times 10 to the 23rd. Let's plug that in one more time. We're going from molecules to grams. Okay, from molecules to grams. Sorry. Okay, so I need to put molecules on the bottom. What goes in this middle section right here on top? Molecules to moles. Good. That's got to be our middleman. Oops. Okay, now I want to go from moles to what? Grams. So grams of NaOH. Moles always, always, always gets the 1. How many molecules are in 1 mole of something? Good, 6.02 times 10 to the 23rd. And our molar mass of sodium hydroxide? I got 39.99. Or 40 grams.
That's right.
Put the NaOH on every single one.
For these problems, it's not as important. When we start getting into using multiple compounds, it's going to be really important. So I just want you to get the habit started now. Did we have about this? 41.46 grams of NaOH? Yeah? You got what? 39.99 for your molar mass? Or for the whole answer? Did you multiply by Avogadro's number and then divide by Avogadro's number?
I got 40.01 because. And
I got 41.
I realized what I made my mistake.
Okay. These numbers look similar, so make sure you're careful about which one you're multiplying and which one you're dividing.